Hi everyone, welcome back. Today's video will be about pH. In this video, we will explore the definition of pH, why the measure of pH exists, the equation we use to calculate pH, an example of calculating pH, and the pH scale. If you want to skip to any of these sections, you can do so by clicking the timestamps found in the description section below. All right, let's get into the video. At the simplest level, pH is a quantitative measure of a solution's acidity or basicity. We learned that acids release protons and bases take on protons. Therefore, a solution's acidity and basicity depends on the amount of protons found in the solution. Now, you might wonder, okay, that's not difficult to grasp. Why can't we just count the amount of protons and classify a solution as acids or bases depending on that? And you are correct. You can do that. But when we're dealing with ions that are so tiny and are present in such large quantities, the amount would be impractical to actually count and discuss in terms of real numbers. So scientists created an easier measure, which is the pH. Simply put, pH is equal to the minus log of the concentration of protons. Therefore, pH is a simple calculation where you get the negative log of the concentration of protons in a solution. P is used to represent minus log, and H plus within square brackets is used to represent the concentration of protons, or again, proton meaning a hydrogen ion. Let's understand this by using an example. Consider this question. What is the pH of 0.0235 molarity of hydrochloric solution? Now, if you recall your chemistry, you know that hydrochloric acid, which is HCl, is a strong acid and therefore will dissociate completely. So in this case, 0.0235 molarity of hydrochloric acid would give you equal amounts of H plus and Cl minus, meaning the concentration of H plus that we would get is 0.0235 molarity. So all you have to do to find the pH of this specific solution is to input 0.0235 molarity of protons into the pH equation. The pH in this circumstance would be equal to negative log of 0.0235. This can also be written as pH equals negative log of 2.3 into 10 to the power minus 2. This is just the initial concentration represented in standard notation. Writing the equation in the second way that I mentioned gives you an easy way to ballpark what the pH of a given solution is, especially for the MCAT when you don't have a calculator. Having an estimate or a good way to ballpark an amount would be important and would save you a lot of time. So you write it in the standard notation and your pH would be around the value of whatever the 10 to the power value it is. So in this case, the pH would be around 2, meaning when you write an amount in the standard notation and you always get a 10 to the power value, that is going to be the value at the top is going to be closer to what the pH would be. If you add it to your calculator, you will find that the accurate value is 1.629, which is very close to 2. Again, for the MCAT, estimations are good enough. You don't have a calculator and they don't expect you to make these time-consuming calculations. And the answers that they usually give as response options are quite far apart, where having a ballpark or an estimate would be sufficient to pick the right answer. So now we know how to calculate the pH, but a number means nothing if we don't know how to interpret it. So this is when the pH scale comes into play. The pH scale ranges from 0 to 14. Roughly speaking, If a solution is in between the pH ranges of 0 to 6, it is considered acidic. If it is between 6 to 8, hovering around 7, it is considered neutral. And if the solution is between 8 to 14, it is considered basic, or in other words, it is considered alkaline. So the lower the pH, the more acidic a solution is, and the higher the pH, the more basic or alkaline a solution is. This is a little counterintuitive, and you might be tempted to think that because we are using the concentration of H plus ions, also known as protons, in a calculation, the higher the pH, it would likely represent high H plus concentrations, meaning it would be more acidic, but this is not the case. You need to remember that we are taking the negative log. So the pH and proton concentration are actually inversely related and not directly related. So that's it for this video. I hope this was helpful for you. If it was, please give it a like, and please subscribe to the channel. It helps out a lot. And until next video, I hope you have a great rest of the day.